got a video today we want to talk about that expands more on the last one we did, which was about noise sources in your audio environment, like computers and electronics and basically everything that plugs into the wall is where we pinned it down to. We narrowed it down. Everything that plugs in could be a potential noise source. So it'd be a good idea. That was a long enough video, so we didn't have time. So let's talk about solutions for this, potential solutions for this. And this could be a while too.
There's a lot to talk about. It really is. And that's the unfortunate reality. It's very complex. It depends exactly on the gear you're running and the types of problems you're having, which, of course, most people don't know. So that makes it a little bit more complicated as well.
Well, and from a distance, neither do we, totally. I mean, no one does unless, you've got sophisticated test equipment and you're in your home and you're watching things and what's happening. So the reality of it is no one over the phone is going to be able to necessarily pin down every problem.
It's difficult to diagnose.
Nor are we.
Well, I just ran into this with my computer, and it's just keep adding new things in over time, and eventually just wires going everywhere. Yeah. And you don't realize how bad it is until you start running into problems where if you kick some of the wires, you hear through the speakers or something. Oh boy.
That's actually a fair point. That's always a good starting point, especially if you're having issues. Make sure that the distances between cables, especially important cables, is as considerable as possible. You want to separate physically the wiring, because although things are shielded, shields aren't perfect, and shields are only good for certain frequencies, and they don't necessarily attenuate enough of the noise for it to not be an issue. It depends on the sensitivity of the piece and what it's doing. Sometimes it doesn't matter, sometimes it does. But best practice, if you can get the cables physically separated, it's usually a benefit right there. Yeah,
and primarily you're looking at separating the power cables from low-level signal cables like interconnect, USB. Yeah. Basically power should stay away from everything. And when we say that too, it's okay if it's not necessarily an issue if they cross over somewhere, crisscross. That's okay. But when you start running them parallel to each other, next to each other for any length, that's where you start running into problems, because what happens is the noise or the current draw or the magnetic field from one cable is now coupling into the ones next to it. So you're trying to avoid that coupling effect, and we won't get into the details of it. We could, but it's another video altogether, and most people don't need to know that. But bottom line is that you want to try to keep high voltage cables or AC cables at least a few inches apart from everything else, and even from each other if you can.
Yes. The thing to note is the signals couple more efficiently between the cables when they're closer and when there's more surface area close. So in that theory, the worst thing you could do would be to say zip tie all the cables together.
Yeah, right.
And sometimes people do that. They'll have AC cables right next to other cables, low voltage signal cables. AC to AC, it kind of doesn't really matter, especially if they're going to the same circuit. It's going to the same place anyways. It doesn't make much of a difference.
It can if one is drawing a significant amount of current, like on an amplifier, and the other is doing line level gear. Because now the AC cord that's got variable current flowing through it is radiating a much larger field than the stuff drawing a consistent 10, 20 watts.
Yeah,
way more so.
But comparatively, that's a minor effect compared to the AC next to low voltage signal cables.
Voltage for voltage, absolutely. Yeah, because you're talking a 10 to 20 to 1 ratio if you're dealing a AC cable versus a line level cable.
Right.
And particularly if you're running like a phono stage or something like that, or a phone.
That's messy. You'll know that right away.
You're talking.
I had to deal with that.
A lot of gain in those amplifiers.
Yeah.
They're sensitive to anything getting near.
Oh, yeah. Yeah, you look at them wrong and you get hummed.
Same with the turntable. It's a floating coil of wire. It's going to pick up everything near it. And then it's going to get amplified 50, 60 dB by the phono stage, which is about 2 million times?
It's a lot.
It's a lot.
Yeah, very sensitive.
So it's sensitive to noise.
Well, that's when I found out, because I moved my powered monitors onto stands separately. So it worked out that it was like the worst case scenario where the analog signal to them and the power cords both were right next to each other the whole way. So it was like worst setup possible. Because I didn't even think, I was going to move them. And I didn't change the wiring or anything. And it was like pretty bad.
Well, and I think people that have owned turntables for a while get that because they've dealt with it. But I'm sure there's a ton of people actually new in the industry with turntables that can't figure out how to give it that slight hum in the background.
Oh, yeah.
And it's really experimentation. It's trial and error. Move things around. Move the turntable. Your turntable and the cable coming off, it could be picking something up in the wall. The wiring in the wall has a Romex, which is a flat cable. It's not twisted pair, which means...
North America.
in North America. I don't know. Do they twist it in other places? I don't know.
It's quite different all over the globe.
Yeah. The issue is that, though, is the wall wiring wasn't designed for noise dissipation or not. They don't worry about high frequency energy. It's designed to supply 50, 60 cycle. That's all they care about. You got the voltage at the other end, you're good to go. And so, it's not made to draw noise away. It's not made to reject it. And it certainly can throw a large magnetic field if you're drawing some juice to it, particularly if it goes to another part of the room. That you happen to have an electric stove hooked up to or something.
Oh, yeah, actually, yeah. The problem I ran into was my turntable had an external power supply, and I had a little phono preamp, and I put it next to it, and it picked up the hum from it. Now, I couldn't figure out, I'm like, everything seems fine, but yeah, you could hear the power supply through the pre.
Yeah, which shows to go even if you got two boxes that you think are metal and are shielded in themselves. The reality of it is the chassis becomes part of the ground.
Yeah, and move it like 3 shelves
and
up.
It's just as susceptible to radiant noise from a small transformer and a device next to it, or a power amp. So, really, when you've got minor little hum issues going, then you really got to experiment with placement, move the cables about. You sit there while the room's quiet, nothing playing, and you just kind of like move things. And just see if you can minimize that. And don't only look for one thing. Everyone should keep that in mind. This noise is additive. It's a combination of things that gets you to the ultimate noise level you're at. So what you're trying to do is roll these one thing problem at a back, roll it backwards, till you get to as quiet as you can.
We probably should note that for most people, this isn't really like a significant issue. This isn't something you should be fearful of. It's just a consideration. Because for most people, it works fine.
Yeah.
But minor improvements can be made, oftentimes just by moving a cable, just by paying attention to how things are laid out and understanding that shields aren't perfect. They don't reject all noise all the time perfectly, and making sure you pay attention to how things are plugged in and where they're plugged in. Because sometimes you could have 2 different appliances plugged into different circuits. And those circuits may be on the same phase. They may be on the same circuit as well that goes back to your main panel. But sometimes they could be on different ones. And that may or may not be an issue, depending on how the device is wired. So it's usually a best practice, if you can, to put all especially your low power stuff, on the same circuit. It just helps mitigate issues like that.
Yeah, technically you should have an entire system on the same phase of the home.
Right.
And if you don't understand that, you probably should talk to an electrician or somebody who can explain it, because that's going to take another 5-10 minutes. But but bottom line is, if you get your audio system, different components of it on 2 different phases, that will almost invariably give you some sort of pretty good hum, depending on what you're doing.
Well, I ran into this too. Yeah, I had monoblock amps and had them plugged into 2 separate outlets.
2 different breakers. Yeah. Bottom line is the breakers need to be either all odd or all even numbered, at least in America. I don't know how they work it with the 230, 220, 240 volts. In the UK, it's like a series chain. Everyone's got different, but in
a lot of countries use single phase.
Yeah.
North America runs split phase, which is very different.
Right.
It's kind of sort of like 2 phases, but technically it's a center tap 240 volt transformer. Which
we're going
is
too deep.
Strange, but yeah.
Yeah, we're going too deep.
Right, but most countries either are single phase or 3 phase. Except North America, it's split phase.
But bottom line is, try another outlet, or a lot of times the solution is, I've had people take an extension cord,
that's what I
bring it from another room. If you're blaming like something else on a circuit in the house, you can take an extension cord, bring it from a room, and plug the whole system in that extension cord, and see if the problem goes away.
Yeah.
If the problem goes away, there's something going on with the circuit coming into that room. But anyway, we're getting too deep into this. But that electrical is a huge issue, and it's something that for solving one problem, it's a 20-minute, 30-minute project, and that's just for that problem. There's 20 different ways that problem could manifest itself, so it's beyond this video.
Yeah, and those are the glaring. Those are the. I know I have a problem.
Yeah, that's a
usually those are pretty audible. Yeah, they're not minor.
Yeah.
So we'll get back to the minor stuff, which is like more or less a hiss, background noise, lack of just blackness, which is hard to perceive until you hear it. When you hear the noise go away, typically that's when you're like, wow, that's really quiet. I didn't realize I could get that quiet type thing. And that's what we're going to cover a bit more on, which is the high frequency energy side of it. And we touched upon this with computers. The computers generated, electronics generated. And we should probably just briefly cover ways to mitigate that. Like Like one thing I know people do is for let's say the source is a computer. Well, a lot of people have gone to streamers, dedicated streamers, not necessarily PC based. You know, some of them are on Analytics, I think.
Well, they're basically computers.
Some are custom.
They're designed differently. Yeah. Usually the computer inside there is a small single board or something that's much smaller physically, so it's easier to isolate it with greater distance. Because the big issue you have with a computer is the physical size and the separation of components. It basically just means there's more antennas in there to be able to radiate and pick up random noise from the areas.
Well, that and you're stuck with kind of the stock solution PC boards that they make.
Yeah.
Where these guys are customizing the board to physically drop the noise level. They're paying that particular attention to the layout.
It's an integrated system.
It's made just for streaming. It's not made to surf the web with or play games.
I mean, you might be able to.
I'm a streamer.
No, it might be physically possible.
Yeah, well, maybe. Yeah, well, maybe if you build your own. But a lot of people do build their own if you're technical enough, you know. But even then, you'd have to you really got to have the means to measure the noise to know if you're actually doing a good job of it. Because as we discussed in the last video, these noise levels can vary from board to board, power supply to power supply. There's no
huge
you can't
variation.
predict the variation from a manufacturer, whether it's going to be one could be better than the other.
And even beyond that, it depends on the load of the device. Yeah. Sometimes you have the device that may be very quiet, may have, with the things that people typically measure, may have very low ripple. But it may only be that state in certain load conditions. It could be that ultra low load, it actually has higher ripple than a medium load. Or very high load, it could have very high ripple too. So it really depends on how you load these things. You got to pay attention to that as well.
So bottom line, by getting a dedicated streamer, we're talking, I think they make them for sub $1,000. You can get them for $20,000 and up. So these things, we're talking US dollars. So these things are expensive. Orinder makes really nice stuff. And there's many other companies that make streamers that are dedicated. You could probably the decent stuff's in the mid few $1,000 range or so. That's where they really paid a lot of attention to the power supplies and the noise level and so on.
Well, you hope.
Yeah, well, you hope.
But it basically is just a dedicated purpose-built computer. So it's not immune to the issues. It's just they usually work to mitigate them.
Yeah, most people that get these things noticing pretty instantaneous change when they go from a PC or to that. I mean, I think depending on how bad the PC was.
Well, yeah.
I think there's usually a pretty stark contrast on any higher resolution playback chain.
They're putting a huge buffer between you and that PC.
Yeah, right. Yeah, or just wiping it out altogether in the system. No more PC, just a dedicated device.
Well, I guess you could technically just not even have a PC, like right from your phone directly to a streamer or something.
Well, that's not a bad thing at all, actually. I mean, when you think about the dedicated DACs, like the Saga DAC that we sell. I've used that multiple times. I use it all the time. In fact, with now that I'm streaming Apple music from Apple Music, I use an iPad typically as a source, and it actually works as a great source with the Camera Connect USB to a full-size USB cable.
It's pretty good.
And it works very good. In fact, I've used an iPad as a source going into a dedicated streamer, and pretty much compares to the streamer in terms of not noticing any kind of difference in noise levels. When you get to appreciate what that sounds like, you can hear it going up and down, And bottom line is it's the latest gen stuff is they tend to get quieter and quieter, I think, in their designs, at least sonically speaking,
Well, especially in phones.
Yeah.
Yeah. You used to be able to hear a difference like between an iPhone and just a touch.
Yeah.
But now
yeah, they've gotten really good with that. As sources go, it's not a bad thing to use a latest gen iPhone or an iPad as a source. Going into and most DACs nowadays will natively accept that. You can just plug right in. There's no drivers or anything. It works like magic.
Usually, yeah.
It just plays whatever else you're playing on your phone. It plays through the DAC.
Mm-hmm.
So anyway, that's one way to go. Is just dedicate an iPad to the room or system and use
it's a decent start. Yeah. It's usually less noise than a standard desktop computer or even a laptop. But again, it depends on the laptop because Apple especially now is moving basically towards the same form factor product in their laptops. So presumably it would offer similar noise levels because of the physical design similarities.
Yeah, we've used their laptops at the shows and they work pretty damn well.
Most people do, actually. And one guy actually came to our booth. He's like, why does everybody use Apple laptops at audio shows? I'm like, I don't know. They work.
Yeah, they kind of work. We gotten used to them.
Yeah.
Some people use PCs.
There are a few.
Yeah. But I think it just depends on what you're familiar with. And speaking of PCs, on that note, there are software solutions for this, too, that do help to mitigate problems. Like, the hell's the one we have? Autovana. Yeah. Autovana is one of them that comes to mind. And the software optimizes the computer, I believe, right? It cuts down non-essential systems.
Yeah, allegedly they try to minimize CPU load to keep more consistent jitter and whatnot, to more or less optimize the system to do things only dedicated to music and not do background tasks and things like that.
They like prioritize taking everything from the hard disk, if it has one, or SSD, and putting it in the RAM.
Oh, buffers it. Yeah. You could set that, turn it on and off.
How much buffer you want and everything.
Right.
Yeah.
Basically, it's just software to try to mitigate the potential issues on the software side.
Yeah, which, I mean, works well for just playing music, but if you're combining that with video, we've learned that you can't use a buffer because it delays the sound from the video. You could turn it on and off. But something to be aware of. I don't think you could really use Autovana for watching movies anyway. It's designed specifically to play files. Yeah, our suggestion would be, too, if you go with any kind of software, read the setup instructions for your particular computer. Because there's things like you were suggesting, exclusive mode settings. Right. There's settings that you could use that can change how the software interfaces to the DAC.
Sometimes they work. Sometimes they provide benefit. Sometimes they don't work.
Yeah.
So it really depends on your software solution, what you're trying to do with it, the hardware you have, whether or not it's compatible.
Yeah, there are some settings you should take a look at. And usually this stuff is, nowadays, with the latest versions, they're usually kind of plug and play. But you should always take a peek at what people think are the best settings for you.
It's a lot better than, remember back in the day, like 10 years ago, when we were trying to figure this, every time it'd be like, all right,
brutal.
what did we need to have? What checkbox did we need?
Yeah, things didn't work.
Yeah, right.
Someone would kick knock the USB cable out. You'd have to reboot the computer, restart the software. Yeah. It would just messed everything up. The DAC just lost everything. It was weird how things used to interface, but it's a lot easier.
Now it's just like plug it in and it works
for the most part. Yeah, I mean there's still the solution. Even with trade shows, sometimes when you're running software like that, is you're gonna have to either close the app and open it again. Sometimes you got to reboot the computer. So
sometimes, for the most part, it works.
Yeah, it's usually something stupid that causes that. Like the software doesn't expect somebody to yank the USB cable out the back of the DAC while it's playing.
Sometimes it gets upsetting.
It doesn't like that sometimes, yeah. Anyways, silly things like that. But that's the thing, though, about this whole game, right, is that as you get into this upper echelon of how to solve problems, you tend to create a few others that you got to deal with. The complexity usually gets up there, which is why you see people going with, like, streamers, because, it's kind of a plug and play. You still got to set it up. You got to connect it to Wi-Fi or, or whatever. Yeah, Ethernet. Yeah, if you have Ethernet there. But, right. But
I would recommend it.
Yeah, well, Ethernet would definitely be the way to go. It's a lot easier, especially
it's reliable.
For preventing glitches, yeah. And most people don't have the baller routers required to stream music and have 3 kids on laptops at the same time in the same house.
Then you no longer need to question it. It's like, is the Wi-Fi problem?
Yeah, hardwire is idiot-proof. Yeah. I know when I got my Sony TV, I ran a line right to it, got a run a line right to it. Same with the streamer. I'm currently running the DCS, the Bartok, and it's got Ethernet, and I ran a line to it because I just didn't feel like dealing with any wireless stupidity.
I did the same thing. I had the Sony server, and I ran it wireless, and it was just so slow changing. And then, I wired it in way better.
Yeah, it's really a good idea to get a CAT cable going.
I ran into quite a few consumer bits that the Wi-Fi cards in the thing randomly disconnect for no apparent reason. And I think it's extraordinarily unlikely it's my actual Wi-Fi network because I don't have this problem with any other things. And it's a pretty robust network, but it's common enough for the Wi-Fi implementation on a lot of hardware to be bad. And they just slam in like this stock off-the-shelf thing, and it doesn't work reliably.
It's like going back in the early days of phones and stuff or anything. When you think about Wi-Fi back in the early days, the routers were constantly an issue in the home.
Yeah.
Mm-hmm. You didn't know what router to buy,
It's still there. At least now you can get good solutions. The enterprise solutions are very good, usually. aside from the cost.
Some
and
routers are
difficulty
better
to
than
implement.
others. Yeah, they play nicer together better than they used to. But and that's another topic right there. If you're running a router in the home that's more than like say 2 or 3 years old, get another one.
Pretty much.
It's a bitch to replace. Everything in the house has to be connected to the new router.
And now you got more things that are connected.
And you'd be
than
amazed how much shit you had in the house.
Yeah.
I must have 20 things in my house that connect to the router, and they all got to get reconfigured when you get the new router. But, you only do it once, and you're good for a few more years.
No, you throw it all out.
Oh, you throw it all out.
Yeah, and you move right to enterprise.
Yeah. So anything that doesn't connect, you just
throw
recycle.
Yeah.
You get something new to connect it. Yeah, that works too.
Yeah, I was thinking about that actually. Like I only have like one thing that's still like G or something on my network. I think it's my thermostat. It's like I'm thinking about getting a new thermostat because I don't want anything running
G.
Yeah, old.
Yeah.
You know.
Yeah, on some routers that kicks the whole network down to G.
Yeah.
You got to have multiple networks.
Yeah. Right.
I got air quality
There's
monitors
one way
that
to
run
go.
G.
Oh, there's one. Yeah. Well, you're a baller.
Intermittently, they disconnect.
You're a little crazy when it comes to stuff like that. You probably run a router for every channel of frequency in the spectrum. How many bands they got now?
I only have 2 routers. You got to have multiple access points.
Oh, 2. Okay.
But you don't need more than 1 router usually.
Not for a normal size like house.
Yeah. But I mean, yeah. Wow. Here we go off on a tangent again. But back to noise. We could do a whole episode on routers.
Well, routers. I mean, they're just making noise, right?
Well, yeah, pretty much.
Boat engine makes noise.
Yeah.
They are pretty noisy devices. In fact, keep the routers away from your audio gear.
Just keep everything away from your
They
audio
are not quiet devices.
And make sure it's away from your kitchen, especially if you have a microwave in there.
Microwave. Oh, right. Yeah.
Yeah. So when you're cooking your hot pockets at 4 a.m.
Unless you plug in a toaster and hook it up, you're good. The toaster solves problems.
Toaster?
Yeah, it absorbs the energy and turns it into heat.
Kind of, actually. Sort of, slightly.
Yeah. It's good.
Just leave your toaster on when you're running your microwave.
You got to have a stainless steel toaster with 4 slices. 4 slices.
Okay.
Yeah. It takes the wide slices. Yeah. It's got to draw at least 1,500
Texas
watts.
toast?
Yeah, Texas toast.
Toasters don't take that much power.
Yeah, I know. The 4 slice do. 1,500 watts, baby.
Are they that much?
Yeah.
I don't know.
American toasters. I don't know
they're
about
like 400 to
here.
600 for 2 slices.
I don't know. Maybe they have more. Maybe they have like
energy efficient
toasters. Yeah, it takes like 10 minutes to toast your toast.
Oh boy.
Yeah.
Takes it easy.
Yeah, you want to burn it, man. That's what you want.
Slowly cooking your toast, not toasting it.
So the other thing to consider, and let's go. We probably should have covered this before when we were talking about separating cables, is the cables themselves.
Yes.
And since we're JPS Labs, we started with we've been making cables for over 30 years. One of the design goals in designing these cables, which is my job, has been my job traditionally, and still is to part of it's to mitigate the transfer of energy between pieces of gear. So using particular shield topologies, the way you twist the wire, the way the conductors lay, even the conductor materials and the stranding itself, all decide on how these cables can convey high frequency energy between components, shields and grounds connected between components, and the power cords connected to the wall. All of these are conveyance methods where you can transfer noise from the home environment to the equipment, and vice versa, from chassis to chassis, inter-chassis noise. You got a DAC throwing noise onto the preamps, right into an amp. So, these things all travel through conductor shields. And so a lot of our designs have been thought out to say, all right, we're going to make sure that we can minimize this inter-chassis chatter of noise from occurring, or at least reduce it a little bit as part of the overall design. And there's a number of ways to do it, and that's not a part of this video. But the point is that when you have like this Illuminati AC power cord, it's a 6 pound power cord. It's a 1/2 inch thick shield that we happen to use aluminum particles in this. We also have a copper particle version, the Illuminati 2, which is coming out soon. But bottom line is that this shield is designed to be lossy, and it's designed to take high frequency energy and just dissipate it as heat. And I mentioned a digital AC too, which we designed 20 some years ago for DACs, anything digital based. Again, filter networks in the plugs, RF lossy insulations in the cable itself. And so noise just travels on the cord and just disappears, soaks it up like a sponge. So, and again, each one of these cables has its application for different devices. But the cables can make a difference in how the noise travels through the system And that also helps dramatically. And we use these like salt and pepper and all kinds of Indian spice and you name it at trade shows all the time to tweak out what we do and to tweak out the sound. And we bring a whole complement of them purposely because we can do that. You know, we get somebody's amp and we've never heard before, and it's like it's a little edgy, and we'll drop it down a notch, or another amp that goes, wow, this thing, we could just throw everything at the kitchen sink at it and it never really gets bright or annoying, and we'll just max out its res, right? That's what we do.
I think this is going to be like a 3-hour long video anyway, so we might as well just go for it.
Yeah.
And one issue that I see people frequently misunderstanding is grounds and ground systems. People assume, oh, well, it has a shield and it's grounded. And we already talked to some extent that the shield isn't necessarily what you think it is in its effectiveness, but the ground is the very same way. The ground in your home, at least in North America, is literally a copper-clad steel rod shoved into the earth.
It's useless.
Right? And if you're in a very wet area, it may be practically useful, but in most areas, it's really not as useful as
I think you'd have to be in a lake.
It's not that effective.
A lake bed.
In very specific regions, it works. You can measure your earth resistance. You can get a device that'll measure more or less the integrity of your bond.
I don't remember the numbers.
Earth.
Remember we looked that up, and it's like
it depends on the region.
You're in the
50 to hundreds of ohms.
Yeah,
thousands.
easily. Yeah, hundreds or even thousands of ohms to that rod stuck in the ground 10 feet down. It's basically useless. I don't even know. You know, it's there, I guess, to make people feel better. Mm-hmm. The copper water pipe is obviously a far better, assuming you have public water.
If you have it, but if you're in a newer region, you probably got plastic in the ground.
Yeah, well, that's an issue.
And it is conductive.
Yeah,
but it's not as good.
Because then you're relying on the ground coming from the pole, which I guess is something.
They usually don't deliver ground; they deliver neutral.
Right, it's not really.
Which it may be bonded at the pole to ground, but not to your premise typically. So if you're relying on your earthing to provide this shield with a relative zero potential, it only works that way if you have a good earthing system in your home, which you could put in, but there's approximately 100% chance your home doesn't have one.
None of them do.
It's very complicated.
We've had electricians that, in fact, I should mention that too, talk about cables. We make an in-wall wire that's designed to run from the breaker panel to an outlet. And it's a beefy wire, it's twisted pair. It's designed to replace what's in the wall for high-end audio systems, right? And we invented the category. There was nobody doing that before us. There's just nobody had anything other than your commercial Romex stuff, you know? And we're going back, I think 2003 it came out.
Yeah.
Anyway, so we've worked with electricians around the country who have installed dedicated panels for audio systems, balanced power systems. We're talking multi-KVA, and they use our wire to come out of that with 10, 20 runs to individual outlets, individual components. And we're talking some baller, talking 100, 150 grand just for power,
right? Just
to run power to the systems, And it's beautiful stuff. I mean, when it's done, you're pretty much guaranteed that system will be dead quiet. And it ought to be, right? And usually you got dedicated rooms. This is all going to. It could be a studio application for recording. Anyway, the short story is that, we've seen all this. And those guys, though, when you get a guy that really knows what he's doing, it requires a commercial electrician. Right, because they're grounding freaking buildings. They're grounding tower sites. They know what earth ground really is. You don't get an 8-foot ground, put in a ground, or even two of them nowadays, and call it ground. They know that's useless. I don't even know what it is. It's two rods in the ground. It looks like you did something, but you didn't. It's not doing anything.
Well, we had that problem with the Mazak CNC. I don't remember. Remember we had installed another ground to it? Remember we drilled a hole in the concrete?
Yeah, where do you want to go with that?
I don't know. What were we even doing with
That's
that?
what they recommend.
They
require
which was probably because the machine was so freaking noisy.
Yeah.
That's stupid.
It didn't really do anything.
It's stupid because what they recommend is against NEC.
Yeah, it was a bad way to go.
So technically you're not supposed to wire it like that, but they recommend installing an earth ground for each unit because I guess they thought that in a large deployment, the sum of the machines would create an elevated earth potential.
So one wouldn't do anything.
But one...
Because it's at the end of the line, and that's the only line. What's it going to do?
Yeah, for one machine, it doesn't really matter. I don't think it makes a difference. I would prefer, and that's how we have our machines wired now. The ground goes to the building ground.
Right. Mm-hmm. Yeah, which is a far better ground anyway.
Yeah.
Because it's neutral.
But I think the point to bring across is people think that if you have a 2, 8, 10, 12-foot ground rods buried in the ground, and the system's great, everything's installed to code, and you apply 120 volts to it, not even 240, 120 volts, people think the breaker will trip on overcurrent. It won't. In the vast majority of places, you'll get an amp, maybe a few amps if you have a good ground, but typically less. And so your breaker will never trip. You can have 120 volts potential on that earth, and the breaker will never trip for overcurrent.
The only thing really that earth ground is useful for is for GFIs, where it's a separate reference for ground, where it can see it can see a difference in current draw between neutral and itself and ground itself.
Yeah, it's not much.
And a GFI says, "Oh, current's going somewhere else, like through your body, right? You're going to die." Trips the GFI, so it's only really a separate reference. But again, we're talking a few milliamps.
Yeah, 5 milliamps.
Which is at 120 volts. That's negligible. It can do that.
Of course.
But earth ground won't.
But if you have a piece of gear with a shield on it, and your shield relies on that being at earth potential, it probably isn't. It's probably elevated. You really need to go pretty extreme with either a very deep rod in the ground or like a mesh and conductive concrete and very large surface area.
Yeah, if you're in the south with like a sandy base,
you
you're
need
screwed.
to measure. Yeah, you need a lot of surface area.
You can't even. I don't even know if they bother with ground rods there.
Well, you could do it.
If 50
it's critical
feet down,
in some industries to have good
maybe
earth.
if you go 50 foot down with some sort of...
You got to measure. You got to know.
Well, I know some of the commercial electricians that I worked with in the past doing dedicated panels for the home environment for these guys. They would run these chemical ground rods. Yeah. And I forget how long they are, but they go down and there's some sort of flint device or something. They actually get some thermal. It's something that burns in it, and it melts melts the earth around it, creating a better connection to the earth. I don't know what it does.
Well, I don't know about that.
They're a few $100 a piece. They're
usually filled with like salts.
They're chemical ground rods.
Yeah, and then you got to add more salts over the time as they wear away or something.
Yeah,
I think conductive concrete is a better solution these days.
Yeah.
That seems to be the play.
Dig a big hole, fill it with concrete.
It's outside of things we deal with.
You do like a mesh, pour concrete in it. Yeah, they got like little conductive puck things you could bury too.
Yeah.
So they don't corrode over time.
I've seen the mesh setups, and that requires like excavation. Basically,
it's a big ordeal.
That's a new build. Yeah, you
need surface
basically
area.
You're putting 100 ground rods all around the perimeter of the property,
right, yeah.
and all tying into one wire to the breaker panel.
But you could get a very good bond. You could get sub 1 ohm to earth in most every region.
Yeah,
it's just expensive usually.
And then the question is to what end?
Right, very minor benefit usually.
Yeah. At this point,
you're not just putting it in for fun.
But if you're doing that, that's an earth that works.
No, nor is it free.
Right. If you have a standard house with a standard earthing system, in most parts of the globe, it probably doesn't do what you think it does. Yeah. And so that's why you have things like lossy members here that try to dissipate the energy rather than just dump it on what people assume is a perfect earth ground.
And that's the thing to cover on here is that even to that end, let's say you had the world's most perfect earth ground at the breaker panel, it would matter none to the noise in your room, in the home, in the environment, because the wiring in the wall can't transfer the noise through it to the panel, to earth ground. The noise never gets there. In fact, the cables in the wire become antenna and radiate that energy out in the air. The high frequency energy never makes it to earth ground. Earth ground was never designed to carry high frequency energy.
I think that provides clarification. It's not that it won't make it there. It's just the vast majority of it will be radiated before it gets there.
Well, it just turns every different length of wire in a tuned antenna at different frequencies. So every interconnect, every power coordinate system, every one of them being a different length, not equal, means they're tuned at different frequencies, and everyone will take a share of of that energy of high frequency.
Yeah.
But you're right; it acts as a reference. But the reality of it is, most of that high frequency energy is dissipated through the system, through the cabling somewhere,
right.
And it manifests itself as a raise in the noise floor of the system. And there's no ifs, ands, or buts about it. That's what happens. It's got to go somewhere. It's kind of like lightning. If anyone's ever watched lightning, like videos on lightning, like serious, like how it travels, it's got a mind of its own.
Kind of, yeah. It finds the lowest impedance path, right?
Yeah. It's not really random, although it looks random. Yeah. It's kind of it's almost like got a plan as it's coming down.
It's really complicated because the very act of it existing, and as a result, heating causes some change in what you would predict its path to be.
It looks random. It might be, but it definitely has a plan, In fact, people probably don't even realize that the lightning hit goes down from the ground up, not up down. Well, the electron flow.
Yeah, go watch some high-speed footage of lightning.
It's
strikes.
weird.
It's
totally counterintuitive.
It makes the connection first, then the current flows, and it's nasty, or something like that.
It's a lot of energy.
Yeah, a shit ton of energy.
It's a little bit different
in a split
than
second.
what we're talking about here. Now, usually noise in the ground system we're talking about is very, very low energy, incredibly low energy. But that doesn't mean it doesn't exist, and it doesn't mean it doesn't affect some gear. Some gear you might not notice.
But it takes
Other gear, it's big.
It takes these same rather unpredictable random paths that unless you're highly experienced in knowing what those are, you'll never figure it out. You're not going to go and oh, that's a bad path for noise, or that's a good one. You're probably never going to figure it out. So the best you could do is try to minimize giving it a clear path to the gear or through the gear.
Pretty much.
Which is what we do in cable designs, and you're trying to minimize that path, that pathway, so that it doesn't find itself running through all the traces in your PC boards on your, with an amplifier or a preamp, and therefore capacitively coupling internally or getting into the electronics. And that's what you're trying to avoid. And that's something else to cover too. People don't realize that the noise paths are internal too. Once they get into an RCA connector or a USB connector and they bleed through, now they're on the trace patterns, they're in the internal wiring, they're in there. And they every piece of gear is going to respond differently to that same noise. And you can put a piece in there and it's dead quiet. Another one hums like a banshee, hisses. It just totally depends on the internal design of how it's dealing with your environment. And there's a lot of shit to know about this. And it's some of it's trial and error. Most of it.
Kind of.
You never have control over it.
Usually it's pretty much just measurement. You change things, you measure it again, see how it impacts it.
Or listen.
Yeah. Depends on the levels you're dealing with.
And that is a problem. It is complicated. But,
yeah.
But in terms of simple solutions, I think we kind of covered it. We've got a one-box solution being, buy good gear designed to drop noise. Replace pieces that are going to be noisy with something that isn't so noisy. Pay attention to the layout of cabling.
That's very important.
Yes.
Especially with turntables.
Yes.
Well, turntables, that's super audible usually. Yeah. You can move a cable and just like the old rabbit ears on top of your TV, you move them, you see the picture change. It's kind of like that.
Yeah.
Now, that still exists with digital, just to a way less significant degree. So it's not that you can't hear it, it's just much harder. So when it's all additive and you've got 10 things going wrong, it's really hard to pick that one out that's really making the difference.
Well, it's actually it's like everything in audio. You're trying to step by step remove these faults in the system. It's like peeling away the onion, so to speak, is the analogy, right? And you're peeling away layers of the onion until you get to the core type thing, and it's the same thing here. It's like, you get rid of the most offensive problems first. Now all of a sudden, less offensive things show up that you can now work on that were masked by the more offensive things, and it just keeps going and going. People do this in video too. For some people, it's way easier.
Problem.
Yeah. I mean, you get a nice picture quality, and you start to realize all kinds of shit messes with that. It's the same deal. Some people are attuned to
things are so much more complicated than people expect once you start digging into it. And honestly, almost everything is like that. The simplest of things, the most trivial things, can be actually very, very complicated when you want to take it as far as humanly possible, as far as we know we can.
Yeah, look at Tesla, making a new battery, right, for their cars. Can you imagine how many trial and errors they went through?
People don't have a clue. It's like that in all industries.
I mean, it's the same deal. How many problems they're trying to resolve to just make the perfect battery?
It looks simple.
Then even when you have what you think is right, then you got to actually use it and see if it actually works the way you think.
Yeah, right, over time.
Yeah.
But
things don't always work out.
But technically, that process could never end.
Oh, yeah.
And it shouldn't, and it probably won't, right?
Well, that's the hope.
Because, as you always say, things can always be improved upon.
Yeah.
Well, they really can.
You
think something's perfect, but then look 10 years earlier. People might have been saying the same thing. And as time goes on, you always find new ways. Well, you hope you find new ways. And the goal is, of course, to continually iterate. You find the new, least significant issue that you could tame, most significant issue that you could do something about. And you take care of it, right? And you improve, you move forward.
Yeah, I think processors are like the ultimate of that. They're always like, 32 nanometer will never be reached, right?
Yeah, we've been hearing that 10 years.
And then it's like, 14 will never happen. 5, And now we're at 5, but
We'll never go to the moon again.
Well, that's different.
People said that at one time too.
True.
We'll never get to Mars.
Well, we've never been there yet.
We'll see.
Yeah, but rovers have. Hell, if you get a rover there,
Yeah.
it's not just a matter of time before they put some sort of rodent in the thing and see if he makes it right.
Oh, yeah. I don't know if that's practical, but maybe.
I don't know, something. Maybe an amoeba. Oh, a group of amoeba.
Yes.
Yeah.
A banana tree.
A banana. Oh, that would, there you go.
Oh,
yeah. With bananas on it. Well,
Yeah.
wait, just beginning to grow bananas.
Grow bananas on Mars.
By the time they get there, they might be ready to pick.
You got like a greenhouse on the spaceship?
With bananas.
Yeah,
on
why
it.
not? A miniature banana tree. Yeah, doesn't take up a lot of room.
Mm-hmm. Very compact.
Yeah. With an automatic watering system.
I'll email that over to NASA.
Or it's
going to
need some sun, though. How do you get? Well, that's no problem.
They got sun over
You
there.
just need a window.
Sun. Yeah.
You got that?
Mm-hmm.
All right, we got to make sure it gets sun at least a few hours a
But
day.
you got to take into account that you're losing the amount of light the further away you get from it, though.
Yeah, that's true. So it needs
Different
more
bananas.
sun. We need to put it on the bright side of the planet, whatever that is, if it even has one.
Well, it's kind of, rotating like Earth.
Oh, yeah.
You
How
know.
long are the days on Mars? I don't even know.
It's pretty close, I think.
Oh, so no problem. The tree will
It's
be
probably fine.
like being at home, except a little bit less oxygen.
A lot less.
Yeah.
You'll work out the
Can you plant a
technology.
banana tree on the Martian surface?
Definitely.
Well, you
Absolutely.
could,
I've
it'll
done a lot of
It'll
research
die.
into this.
Yeah, I
for
imagine,
sure.
I imagine it's going to have an issue.
Yeah, I guess we're getting pretty off.
As
off
usual,
topic.
yeah. You know how much noise must be on the Martian surface from the sun?
Well, we got that same
Well,
problem
it's different
here.
noise.
That's true. We never talked about noise from sunspot activity. I don't know. I've never correlated that to the sound of audio. But I know. So I brought this up in an old video. I can't remember. I had a customer once call, and we got to talking, and his wife used to be sensitive to sunspot activity, where she actually could tell you whether there's sunspot activity from the way her body felt or something. I don't know, but she was sensitive to it, and she taught him how to be sensitive to it, and he started to figure it out too. Now, for some people, this sounds crazy, but you think
For most
about it,
people,
it's
yeah.
quite possible. I mean, there's a lot of energy being rated by that ball, right?
Well, that is true.
Yeah, I mean, and it's possible. I mean, some days I walk outside and it's sunny out, and I'm like, damn, this sun feels hot. I mean, and I'm not saying that's equated, but it seems like it's like for some reason the rays seem
Yeah.
stronger than normal. Could just be me, obviously. It's a
Well, you don't see
subjective
the
thing.
UV.
Yeah, the UV.
No,
yeah.
that's true. I have no way to measure it, but it sure as hell sometimes feels really hot, and some days I go out and it doesn't feel as hot, but it's still sunny. So go figure. I don't know. Maybe that's it. But I think it was more of an emotional feeling than it was a feeling of heat or energy.
Probably.
Yeah. And we won't even go there because I don't know where. I've never been taught or learned that. But bottom line is, it's funny what things humans are sensitive to that we.
Pretty much everything.
Yeah, pretty much
Yeah.
everything. Yeah, that we, then you'd be surprised what affects you and what doesn't. And of course people say we talk ourselves into all kinds of shit, and we do.
Well,
You
that
know?
is the truth. Though.
Yeah,
You can.
Absolutely. Yeah, we do.
Yeah. That's
Yeah.
what I don't want people to take away from this, to think that, I need to do something with all these cables and the noise.
Yeah. Well, yeah.
No.
Don't get paranoid.
You can
because
only do so much.
It does get it's a little tense to talk about all this stuff and think about, oh my God, so we're piling this shit on people if they've never heard about it before. They're like, now I got to do all this stuff.
Right.
Start digging in your backyard. And
Yeah, you don't have to.
Well, I was trying to get conductive concrete, but it's really expensive because
Is it carbon
I can't
infused?
find it. I'm not sure. Something like that. Yeah.
yeah.
I'm not sure if anyone stocks it locally. I couldn't find it.
They make
Shipping's
conductive
very
paints.
expensive.
They make acoustic.
Trying to
paints.
get sub 1 ohm to earth.
You need to go 50 feet down.
yeah, start pounding
You need
I-beams
depth.
into the
You need to hit the water table.
See, I hear you don't need to do that.
That'll work though.
Conductive concrete, some chemical rods, big hole.
And while you're at it, you might as well drill a
Couple
gas.
meshes. Just do it all.
Drill a gas wall while you're at it, because you'll probably hit gas if you go far enough down, and
think so?
you could run your house.
I was
off.
going to do a 50-foot ground rod. I hear that's impractical in most regions.
Yeah, it depends. If you hit a stone, you're in a real issue,
Well,
bedrock.
sometimes you could push through it.
like a big rock. Yeah,
You get a rotary hammer, the little adaptery thing,
you need one of those oil well drilling
the
guys.
couplers for
They
the
got the
ground
machine
rods.
for that. They just do like
Yeah.
10-foot sections at a time or something, right? They just keep going down.
Yeah, you do that,
Yeah.
but then you fill it up with conductive concrete and a core
Oh, now we're talking.
with a ground
And a
rod,
really heavy wire,
the biggest wire.
like a triple aught.
No, just make it into a
Copper.
copper bar right to your house.
1,000
Ooh,
MCM.
yeah. Actually, that's the better way to go. You need to run flat
Yeah.
copper, because that's better at impulse responses. It's better at. They use that in for lightning protection in
It's lower
tower
impedance.
sites and stuff. They run the flat. You got to have
Yes.
flat. You can't have round wire.
It's kind of hard to get that into a residential premise, though.
Yeah.
I don't know of an elegant solution for that.
Yeah. On that note, we really need to wrap this up
Yeah.
because we got to get going.
Oh,
We took it too far. In fact,
I don't think we took it far enough.
In fact, you called. You said it's going to take 3 hours. So what the beep?
I could talk for like 3 hours about ground rods.
Yeah, tell me. I know we could all talk about it for about 3 hours, which it's going to require a couple beers at some point. At least for me. I don't know about you guys, but
I don't know.
You'll need a Pepsi.
Yeah.
Yeah. I don't know what. You might need some scotch too.
I don't know. I got to go home pretty soon. You know.
Okay. The rambling's over on noise. It's something to be aware of, everybody. On that note, take care of yourselves. Thanks for watching. Give us a thumbs up. Take care.